For anybody who's seen a rocket launch, there's this moment where a rocket leaves the atmosphere and enters into the vacuum of space, where there's this deafening silence, and that's where our job begins. That's our mission.
In the last 10 years, about 10,000 satellites were launched.
And if we exclude Starlink, half of these satellites actually did not carry any kind of propulsion on board.
If you think of it for 1 second, you come to the conclusion this is a huge problem. Having propulsion on board allows you to maneuver. That means correcting orbits, changing orbits, avoiding collisions, and very importantly, by the end of the lifetime of the mission, you have to get the satellite out of orbit to avoid becoming space junk.
So if you have a propulsion system, you can basically counteract that drag and have a much longer lifespan of these satellites.
And if you think of it, if having propulsion on board gives you all these benefits, why don't all the satellites have propulsion on board?
Because they simply could not fit them. So at IENAI, we're trying to innovate, we're trying to disrupt the market. We're trying to create a new kind of electric propulsion system that solves the efficiency problem at low powers, but that it is also scalable in a way that it meets the demands and requirements of specific satellite platforms and satellite missions.
So we created Athena. It's a new electric propulsion system which is not based on plasmas, but it's based on the electrospray technology.
And in fact, the two key aspects of the technology are in the name. First, electrospray is a new kind of electric propulsion technology that is based on the use of ionic liquid propellants, or molten salts as we call them. And secondly, the use of nanotechnology, which is required to manufacture with the precision that is needed in the core components of Athena. The incredible engineering behind Athena, as well as its multiple innovations, were needed to bring a new world-class propulsion system to the market. A low-power, highly efficient and compact product which minimizes the impact over the platform and mission with low thermal loads and a low signature plume. And best of all, Athena is scalable and modular, delivering on our vision of one-of-a-kind propulsion systems for one-of-a-kind space missions. In general, how does one choose a propulsion system for a mission?
The selection of a propulsion system, or in our case a configuration of Athena, is a delicate balancing act. And this is because propulsion is innately intertwined with many other aspects of a satellite's mission, both the hardware and the operations.
And that's why we developed 360, our mission space mobility software, which is available in the market today.
And 360 is fundamentally made up of two key features. A digital twin approach, which allows us to simulate spacecraft and mission operations with a high degree of fidelity. And second, an embedded optimization algorithm, which allows us to make better decisions when it comes down to selecting different kinds of subsystems for your propulsion system, defining mission operations, and of course, choosing the right propulsion system for your mission. It can work in tandem or independently of Athena, but if it is working with Athena, it can provide the best configuration for a particular mission and platform.
Additionally to 360, this year we are kickstarting the development of Orbital, an operations software which will allow our clients to optimize in real time the propulsive maneuvers. Orbital will allow the mission operators to make the best decisions when it comes to spacecraft maneuvers.